Now even tougher question is this, where we have to find the charge induced on the solid sphere, which is this inside one, and also it is grounded. And the second part of this question is we have to find the potential of the shell. Now to solve this, obviously we are going to use ideas of our previous question, but it's not going to be that easy. So first of all, right off the bat we can say that firstly assume charge x here, from earth it came, to make potential 0 inside there because it's metal, minus x here, x here. Now we are going to divide this into two systems. System 1 being the inside part, which is just the sphere, with the sphere inside, grounded just like me, having x minus x here, also x here. Here it will be uniform x on the surface because the charge is not there in this system, the charge is there in this system. Here is the system, another one, and here we have charge density with 0, obviously 0. This is 0, non-uniformly distributed, as we talked in the previous question, like that itself. Now here the idea is going to be, we can just assume metal hole here, and this will arrange in such a way so that field inside will be 0, obviously, and looking here, this will arrange in such a way so that field inside is 0. So obviously this x will be uniformly distributed. This minus x, I'm going to erase that because it's looking weird, congested. This x is uniformly distributed, obviously, because no charge, and due to its uniformly distributedness we can find here the potential. How? The potential due to the minus x and the x, it will be uniform first of all. So the potential due to x, the outer surface x, is going to be kx by r. Okay, r is 2a here, 2a, right. From here we can say the field here and there and everything else is same, so here is q naught, k q naught by 4a, and due to this whole system, okay, we have to take whole charge on the outer sphere, which is kx minus x, and this is going to be 0, and due to the inner sphere it's going to be kx by the radius of inner sphere, which is a, this. So from this system, this is the potential at here, and here this is the potential right here. Now if we add these two, obviously we have to equate this to 0 because it's grounded. X equals q naught by 4. Also very easy way was directly doing from here, because the first part is easy because this q naught here would be same everywhere as this there. The field inside the solid sphere is obviously 0 because it's a metal, and it's the fundamental property of metal that field is 0 inside. Thus potential between is potential just at the periphery, I mean the border on the surface of this, which is kq naught by 4a. 4a is like this, and then we can say potential due to the outer shell is going to be obviously 0 because net charge is 0, and due to the charge on the sphere is kq by x. Thus x we get as this. Oh, I mean, minus sign was obvious because we want 0, not 2 kq naught by 4. Alright, this is our answer of part 1, but part 2 is even harder. Alright, so now part 2 is find the potential on the surface of the outer shell. How to do that? To do that we have to assume this again, these systems, this and this. So here we can say clearly potential at here is potential at here, obviously because it's solid. It's actually the outer surface, but we have not assumed the charges here because here are already the charges. And now potential at here is the potential at there. So potential would be kq naught by 4a obviously, but from here potential at here is going to be what? Now for this also we need another level of clarity. Look, there's a system. I'm gonna draw this properly once more. So we have an outer sphere, an inner sphere, x minus x, x. So due to this, look at just x and minus x, hide this x. There will be no field outside. Why? Because in between there's a conductor, so no field in the conductor due to the property of conductors. Therefore, if no field in the conductor outside, why would the field be there? So due to these two, the field is not outside at all. The potential at infinity is potential at this because there is no field, so no potential difference. Therefore your potential is 0 due to these two together. But due to this, there would be a potential that would be kx by 2a. Now to find potential, we calculated x, which is q naught by 4, kq naught by 4 to a. This whole is x. So add this and this. Oh yeah, minus, because it was x was, where am I writing? Okay, x was minus q naught by 4, and this is this. So overall potential is kq naught. Adding these two values, don't forget the minus here, like that. So kq naught by 4a, just take 4 common, a common, 1 minus 1 by 2, that's going to be kq naught by 8a. And then another question was find the potential at point P, and point P is at a distance r from the center. That's pretty weird. Let's just find it out. I'm just gonna erase this system. Oh, x, oh, shouldn't be there. Alright, so P is now a point which is r from center, like take right there, which is the line joining this, and distance from r, distance r from the center, and it's this. Yes, this is our new question. Find potential at point P. Alright, so you solve this. What to think of first? You can see the potential due to this and charge shell is going to be 0, and only due to this and the system is going to be something else. So Here also we can do it with superpositioning, meaning we can draw two systems. One there, no charge inside, this is 2a, and from the center, and there is q naught for a distance from the center, obviously, and hole in the inside there is field equal to 0 because it's conductor. We filled it with solid conductor because there is no charge. As the charge we have taken it to another system is this system x minus x, and we have to find here. So the potential, okay, focus, the potential at center is going to be the potential at PA or any other point in this, and the potential here we have to calculate it using something which is very simple. We can treat this as point charge because we are outside, so k x by r, we put x as q naught by 4 r k, this minus, and due to this it's going to be q naught k by 4a, and this is this. If we add these both, we would get kq by 4, 1 by a minus 1 by r, and obviously a is greater, r is greater than a, so this will be greater, which is positive. I guess so this is right, because due to this the potential inside everywhere would be 0. Yeah, that's it. Thanks for watching. Hope you all learned something new.